Hey guys, we're at Western Iowa Tech here today in our motorcycle lab, and we're going to show you some of the practices that we use for transmission disassembly and inspection. So I'd like you to take a look at what my student has already set up. There's multiple ways to skin a cat on this, but this is something that works really nice here for the fact that what I make my students do is they print the microfiche, and then they make sure and lay the parts out like the orientation of the microfiche. So whether I haven't taken a look at this one to see which way it goes here, but this number 3 is this shaft like this, and then basically it builds up, and you can see as it goes along it's all these pieces. The nice thing that's nice about all this is it gives us an opportunity to, if we're missing something, we can highlight it and it's right in your face. You're not trying to look down at the flashlight or get real intense and be able to overlook something. Does that make sense? So I'm going to focus on this inspection part of this transmission first, and you're going to see us use some precision tools in a bit here too. One thing that's overlooked is that if the shaft is bent. Very overlooked problem. And what do you think would ever cause this shaft to get bent?
Overheating.
Okay.
Locking up, crashing it. Accident.
Locking up a couple sets of gears at the same time or missed shifts. Because when we bind all the gears that are on this shaft just wants to bend. It's supported by 2 bearings on its side. So this is something that definitely, if you're going to do transmission repair, needs to be inspected, and I'll show you how to do that in a bit. But as we just kind of go along here, I just want to point some things out. With me being left-handed, I'm just going to do a demonstration here. And let's say that I'm going to disassemble all my pieces in this direction. What I like to do is take the gear off the shaft and I lay it down like this, because being left-handed, then when I assemble it, I will pick the gear up, put it on. I'll pick a bushing up, put it on. Pick up another piece, and so on and so on. So that works really nice for me. Whatever your method is, it has to be exact. What I want to do is start to focus in here on some good gears, because I'm going to show you a bunch of bad ones here in a second. Okay, so this one's good. It's just a normal little bit of wear. Can you kind of see the scuffing right here where you could tell where the gear that slides into this? Okay, so what happens is this goes in here, be this way. And it basically, as we shift the transmission, these are going to engage, and now we're going to drive this gear. Okay, but you can see here that until it gets inside these holes, it's going to slide across that area and then lock in. Does that make sense? Yeah. Kind of one of the whole rationale behind a constant mesh transmission. All of the gears are always turning, and they're engaging and disengaging from each other. The other thing you always want to do is make sure and look on both sides of the slot. What people forget about is deacceleration. So they'll get really focused on acceleration because the customer says, hey, when I grab a handful of second gear, it wants to slip on me, or it wants to slip out of gear if this gets real rounded. Well, when you decel pretty hard too, you bang the backside of it, and you might have some binding or something going on with the transmission too. It might even just be noise that's the complaint. So we're going to keep looking at, we're going to look at every single one of these with a flashlight, very intentional. And then the other thing is, make sure and look at all the teeth. So like I said, I'll show you some bad ones here in a second. We're going to do a full 360 degrees on that. And then the last spot on this gear is we want to look where the bushing rides. You guys are going to see in your lab sheet, I kind of asked you to describe what this should look like. This one on this transmission is beautiful. What part of the engine does that resemble?
Cylinder.
The cylinder honed, doesn't it? Yeah, look, it is honed. Yeah. So what do we know about honing? It holds oil, 45-degree angle, precision. I like all those answers. So I'm going to trade places here. I'm going to step where Brian is. I'm going to start to go down the transmission and keep doing some inspecting. Just if I didn't make it clear, his numbers on his sheet here represent the number on the actual fish here. So number 5 there, and then so on, just to be clear on that. So what do you think I'm looking for on this?
Scuffing, scarring, gouging. Wearing.
Gouging. I'm going to have some wear. Do you see the shiny spots? Yeah. So what we need to think about is that this bushing rides in here. So what type of gear is this one?
Freewheeling.
That's a freewheeling one, okay? We have sliding that slide back and forth. We have fixed that are fixed to the shaft itself, and then a freewheeling one. So what I'm looking for is those two surfaces to see there's no galling or any problems. A lot of times you guys are going to see on some ones I have over there, this is actually bronze or brass, if you will. And is that a pretty soft metal?
Yeah.
And that's where sometimes you do an oil change and you see those bronze or brass particles in the oil, and you're trying to figure out where they're coming from. It's here. So good Good observation there. The other thing I want to start to point out on this is the fact that we have these holes here. This is, now when you guys did your 2 strokes, we didn't see any of this. So we got these holes here, and we see these matching holes on the shaft. I want you to notice something here. When I go to put this on, do you see how if I pick the right spline, when this gear is riding where it's supposed to, that's how it gets its oil. So let's see if on this one, if it can be put in the wrong position. Nope, oil hole lines up, right? Did they make this one foolproof?
Yeah.
Yeah, so we don't have to worry about this at all. On this side here, it won't even fit. But guys, what I'm saying is there are transmissions out here where this isn't foolproof. It will allow you to offset it, and then you don't have any oil other than splash lubrication. Because on this transmission, we're going to force oil through the center of the shaft from galleys in the engine case. And then the other side will be plugged, and that'll push that oil up in there. And that's also how the shift forks get their oil a lot of times, is through these holes. So it's pretty significant. All right, I'm going to keep moving along here. And the other thing we're going to start to notice is we've got these thrust washers, if you will. We got a real nice flat side, and we have a more rounded side. If you take a look at this washer here, what I'm really wanting you guys to focus on are these tabs. Okay, because when it's laying on the bench here like this, it's not super obvious, right? So what happens here is Brian's told me that he's looked at this pretty careful, and this engages into the washer, and that's what creates a lock on there so that the shim can't sit and spin around. Okay? The other thing I always like to look at too is what do the parts ride against? Does that make sense? The other thing you notice about this gear, do you see how it has this machined area?
Yeah.
Is that wore or is it machined?
Machined.
Yeah. So we could see here, the other thing is the shape of that is extremely similar?
Yeah. Mm-hmm.
Yeah. And the whole reason for a machine surface is so that we can have oil get behind there. Does that make sense?
Yep.
Next thing I'm going to do on this guy is I'm going to look at the ears of the gear here, the dogs, a lot of people call these, that engage into those slotted holes. I'm going to try to look at my splines to see if there's any damage on the spline itself. And then a big area here is where the shift fork rides. So down inside here, can you see where there's a little bit of metal galling going on?
Yeah.
That's pretty minor, and the fact that this transmission had a lot of oil in, I'm not super worried about it. The thing you're really looking at here is the sides. The sides of this gear, people get really focused down in the middle, but they don't look at the sides. Is there a shift fork spinning against that?
Yeah.
Absolutely. And that's what gets the wear, because the shift fork is going to take this gear and slide it one direction or another. So you really want to pay attention from the bottom of that channel all the way up to the top and look for any galling in there. If you got galling in here, you get a shift fork that you know is going to be a problem? Mm-hmm. Absolutely. So a lot of fine inspection. Last thing about this gear, what would you say we need to do to all the teeth?
Check them.
Yeah, check them out. So I'll show you guys some bad ones again. All right, snap rings. Snap rings are always a one-time use, and what we're looking for here is to make sure that we're not bent or twisted real bad. We aren't even going to chance it. We're going to put new ones on. Would you say Brian probably did a pretty good job, Brian and Chris here, at taking this apart?
Oh, yeah.
Because it's not violated, like, it's not twisted like this real bad. You know what I'm saying? Mm-hmm. So they did a nice job of taking that apart. Minimal distress is what I'm asking for on the lab sheet. When I say, what'd your instructor ask you to do, or how to model, how to take off circlips? Minimal distress, and we literally just want to take and lightly drag this off the shaft that it's coming off of. Snap rings here, we'll talk about this right now since we're in here. Okay, what we're going to try and see is if you could see, oh, look at that. Can you see how flat that edge is? Mm-hmm. Let's make sure. I'm talking about this edge right here. Okay, now when I flip this, hopefully this is going to show.
Yep.
Would you agree that that's a rounded edge now?
Right.
Okay, so in every service manual out there, they make a big deal about that, and I'm going to model this from these couple of gears here. This gear here, okay, what type of gear is it?
Freewheeling.
Freewheeling, okay, so does it ever move around?
No.
No, okay. This gear, okay, has to engage into this one, right? Because this is a slider.
Right.
It's splined, it's a sliding gear, okay? Well, if you notice here, in between here, this little sandwich here, we had this washer, and then on this shaft, we have this snap ring that goes in one of these grooves, okay? So what I want to do, I'm going to actually just assemble this up a little bit. Oil holes lined up, so I'm good, right?
Yeah.
The gear here, that would sit right here. This washer, and then we would have this snap ring. Okay?
So you had the round flat down towards the snap, right?
Well, what we're going to do is we're going to focus here on the fact that we got to decide what direction this is being, pushed. Are we pushing it this way, or are we pushing it, this snap ring very well could go on this shaft, could go on this back side over here. I have to look at the fish there myself. But what I'm saying is, if I'm trying to shove pressure against this gear, let's just look at the microfiche and figure this one out here. So we got number 7 is the gear. So we got the snap ring was actually going on this particular one, we got a snap ring that's going right here. Okay? And that's this number 28, correct? I don't think we got a part number wrote down. Oh, there it is. We've kind of moved this stuff around here. So with this here, that means that we got to take a look. This gear is sliding this direction and that direction. So I'm going to go ahead and slide this on here. Okay, this is going back and forth like this. If I'm trying to push that gear that direction, I want to make sure the flat part of the snap ring needs to be in the direction of the load or the thrust that we're trying to push against this. So for this ring to be on this side, we're trying to push this gear off, we want the flat part to have all the real estate down into the groove that it's riding in. If we have it flipped, what will happen is when we push the load on there, that rounded edge will allow the snap ring to open up and walk off the shaft. Does that make sense? But the thing is, it's not that every single one goes the same way on a shaft. So on this actual snap ring, we are going this direct. We're pushing a load to where what's going to stop this from going any further, this snap ring is going to set the distance of where this gear can ride. Does that make sense, guys? Do you see that?
Yeah.
When it hits the snap ring, it's done. So that means I'm going that direction. So which way does the flat need to be? The rounded slide needs to be towards the sliding gear because we're trying to shove it off that way, and we want the most amount of real estate in that direction. What we got is the idea that we have a square edge here, and if I was going to push against this circlip on its square edge, do you see how I get 100% of the real estate? Yeah. And you guys have heard me talk about this a lot, but right here I don't have 100% real estate, so I'm not pushing against as much. And anytime I'm pushing on a round surface, we got to remember that this thing wants to spring open, and we're talking about a lot of force too, aren't we? Yeah. And so that's going to shove that off, causing the gear to disengage. And or to dislodge itself would be a better word, and we got all kinds of problems. So here, this is that drawing you'll look for in your service manual and in your Honda Common, and it's obviously a little more clear. So there you go. How many of you guys have seen this in your textbook, or especially in like the Honda Common manual? Yep. Okay, so they make a big deal about it. Listen to me, there's been nationwide recalls. Since we're doing a YouTube video, I'm not going to pick on the manufacturer, but there was a huge one just, I don't know, 5-6 years ago where people got hurt, and 70 mile an hour going down the highway, 2 sets of gears would lock up. That snap ring was walking off, and guys, it was because at the factory these were put in backwards. So guys you guys at the shops were having to pull these motors, disassemble the trannies, and literally you're putting in a 50-cent snap ring in the right direction to make that bike where it would last forever and say, not have anybody getting killed on it. So this is a big one. Okay, don't overlook this. All right, let me try and set Brian's stuff back up here. Help me out here, Brian, on your order. I believe 28 was a snap ring. Okay, and then we get our gear and our bushing, and then our shaft. We would continue on down along here. We'd watch how these lock in. Here's another gear with some slots. And I want to show you that this is actually a minimal amount of acceptable damage. Do you see where the wear is now?
Yeah.
And you see how, unless you know what you're looking for, this is hard to tell, right? Yeah. So this is actually an acceptable minimal amount of wear. you have to look to see if they give you specifications of how wide this could be. I'm going to tell you, 9 times out of 10, it's just inspect. If any damage or galling, they're going to go through the safe side and say, just go ahead and replace this. This is third gear. We figured it out by counting the teeth and matching it up. And this is not a gear, he wasn't having any transmission problems. Third gear is not one that gets necessarily beat on or rammed on. If it was first or second gear, I'd be a little more worried. Does that make sense?
Oh, yeah.
Because people gun them in those lower gears. Brian, you know, is just doing some cruising this and that. At $91 and this minimal wear, he's going to choose not to replace this. Wait till I show you some really bad ones and you go, okay, that makes sense. I would continue to do all the same inspection for the rest of this transmission. And this transmission looks really good. I think all you need, Brian, are just some snap rings. Is that correct? Correct. So here's what I would do for my parts person, is I would go in here and I would just highlight the snap rings, and that's what you turn in to say, hey, let's turn these into part numbers. Make sense? Yep. All right, let's change directions and let's actually just look at a bunch of bad stuff. This, I believe, was out of I think it was out of a Harley Davidson. Well, as wide spaces as this makes me think it was out of an ATV or UTV. But there's a couple reasons I want to pull this out. It's very obvious what the damage is with this, right? Oh, one whole piece. You think this thing was probably pretty expensive?
Yeah, pretty sure.
Yeah, no doubt. But we've talked about this in class, and I know not all of you have seen it. What do you call this type of gear? Helical gear. Okay, so we said that these run quieter. You get a little better gear mesh. And this is much more expensive when they put helical cut gears in there. So this was a high performance shaft that definitely went bang. Okay, let's look at some different gears here. And we'll start to take a look at where the wear was and what the risk was. Now, this gear here is not bad. It looks to have very minimal wear here. If you start to get into the corners, very, very minimal, okay? But the thing is, with this was out of a race bike, and they just decided that they wanted everything replaced. They, you know, all the labor to get in there, they didn't want to chance anything. They wanted it all new. Does that make sense? So very, very minimal on that one. I'm not too concerned about it. Let's see what we got going on here. This one here, you got some shiny spots starting to go on there. It's not super horrible, but you start to see where it's coming off there. Do you see the oil hole down in there?
Yeah.
So that's how the shift fork gets its oil through there. Super important that those get lined up. So we go ahead and just inspect all this. Now, when you have a rough spot here, but it's not wore super bad, maybe this didn't meet specification on its thickness. Can you see where it's pretty rounded right there? As a little bit closer inspection on this, do you see where this is actually lower than the area right here?
Yep.
And as I drag my pin across there, I could kind of feel that catch. Not super bad, but you know, like I said, the whole thing with transmissions is it's all about what's the risk worth on, you know, trying to save that gear. Another thing as far as design, I want you to notice, do you notice the teeth here, how one side is beveled off, but the other side's square?
Right. Mm-hmm.
Okay, so that's helping for the engagement. As that slides into its mating gear next to it, it helps it roll in there a little better. That's called a lead-in on gears. Okay, so let's just keep going along here until we can find some. Oh, holy smokes! Here's a bad one. Okay.
Oh yeah.
Think that got overused and overused?
A little bit.
Here's the problem for some technicians. It's so consistent that it looks like possibly it was supposed to be that way. Upon, you know, being new into doing transmissions or whatnot, what I want you to notice to build a relationship to, if you looked at where the raw casting was, do you see here how it started to dig in this direction? Mm-hmm. You see how it's getting thinner down here? That's a real obvious clue that this is terrible. This thing's serious need. The other thing is this whole recessed edge, that literally got drug and spun around there. And due to the physical size of this gear, it's a pretty large gear. When you say this is one of the lower gears,
Yeah.
you know, this is probably first or second gear here, so one that gets heavily abused. The other thing I want you to notice is, here's what I talked about earlier about having that bronze insert. Did it have plenty of oil?
Oh yeah.
Yeah, this had really good oil. It's still got its color to it. I'll show you some bad ones. When they're bad, they'll be black. I mean, just burnt up black as can be. The other thing is, if it didn't have any oil, it probably wouldn't have these little divots or these little holes in there that retain the oil. Okay, it gives a place for the oil to sit in there and do its job. They'll be just completely smoked off. Okay, I believe that on this gear too, that they do sell just this bushing separately quite often. So if the gear's good and you just had a problem here because it's a soft metal, what you'll see the complaint is, I'm gonna have to, I don't have the shaft this goes on, so I'm gonna have to model this. When this bushing's good, there's not a ton of wiggle room here, okay? But thing is, another thing, they don't give you a measurement. They'll just tell you to check it out. All of these, with these bushings, will have some of this. So you might be kind of surprised. You go in there and go, God, that seems really loose for a transmission. That little float right there is pretty normal. If you can move this thing all over the place, something's wrong. You should not be able to rock it really out of contact with the other gear. But a little wiggle is a good thing. The other thing you always want to test is, rotating that when you get your new one, because sometimes there's high spots on the bushing and you basically want to mate them together. 50 miles of driving the thing, it's going to mate itself with that soft metal. All right, good indication of a wore one there?
Yeah.
All right, let's keep looking along here. Here's a burned up one. So notice the color of it right away.
Black.
You see how black it is? So right away, what's this probably tell you about the oil level in that transmission?
Oil is out.
Yeah, here's the thing. It didn't get ran long though, because I don't have galling or a bunch of metal-to-metal contact. So what probably happened on this was somebody probably did an oil change, forgot to fill the case, and then remembered. Does that make sense? Is that possibly a logical way that this got so blackened but didn't have a bunch of galling on it? Okay. Possible. Maybe it's a black gear. Oh, here's a good one. Check this out. What do you think how deep the grooves are on that? Where they're rolled off. So this is just like Brian's here. And you can really see over here where it had the wear. That's just going to be nothing but noise, problems. And what happens is, this gear, what happens is when you have that soft edge now, this under heavy load, because here's what's happening. You're going down the road and you give it gas and you're locking these gears, which spins this. Well, guys, that rear wheel, that friction on the ground is preventing, if you will, the friction of the tire on the ground. When these gears are wore, will cause this to slip. And then it'll slam into the next set of holes because the shift fork is saying, no, you need to stay there. But when that groove gets bad enough, your customer will go, hey, I get a bad clunking when I accelerate my bike. Well, what's happening is this. It's rolling out of there because it can't retain itself because this doesn't have a good surface or it isn't deep enough to hold it in place anymore. Has anybody ever actually rode a bike that has had this problem? No. None of your race bikes or anything? Okay, this is what's going on, is it won't hold in place. Now, there are machine shops out there that will offer services where they'll go in here and they'll just machine this and bring it all back to a nice square edge. And then they'll heat treat them. If you do a whole transmission, you'll probably save yourself some money. But if you only got one or two bad gears, it's actually just cheaper to go OEM or original equipment. Drag racers will do a thing called back cutting, where what they'll do is they'll actually cut these at a sharp edge. So they'll actually go in here and machine this at an edge. So normally right now we're kind of round like this, and we're going into a round hole, right? And there's a little bit of taper right here. Well, what the drag racer will do is they will take and machine this like so. And then they'll take the gear itself, I'm going to move it up here, and they'll machine it this way instead of it being a rounded edge. So do you see when you actually put it in direction, those two angled edges will lock themselves together?
That doesn't bind them to
Oh my goodness, they're noisy, banging, they don't last, but if you want to win championships, think you'd back cut your transmissions?
No.
Yeah, this is a racing thing. We don't see this on street bikes or street applications. Do you see the damage on this one? A little bit of stress.
Oh, yeah.
Extremely minimal. This, guys, this is very minimal. We're going to measure the width of this. We're going to measure this pin. This is an area too. Do you see all the shininess on the pin here? Okay, so this is a definite problem with this one. So I'm going to show you some that are good, so that we can compare what we're looking at here. So you'll see here that this is got a little bit of a shine to it. You notice that little corner right there? You know, it's different, right? But it's extremely minor. What you're going to do is you're going to measure the width of this, like so. I'll model this, and you're going to compare this. It's always zero it. I like to use standard. I don't like to use metric as far as my comparisons, but you can do whatever you're comfortable with. I'd measure the thickness of that. I'd measure the thickness here. Now, a lot of times you might get into a deal that actually says it's way larger than it should be. And the reason is on something like this, you might have raised metal. That's actually metal that smeared itself over. So you have to be really careful when you measure it, because if I grab onto that smeared metal, it's going to tell me I'm a lot thicker than I really am. Make sense? But regardless, if you're too thick or too thin, I mean, there's something going on here. So if you notice here, if I only measured right here, could I possibly say that that shift work is in spec?
Good.
It could, okay, but this one's real obvious with the physical damage. What caused that ring?
The bolt got bent.
So it bent over against the side of this. That's what really caused that. So what this does is when I see this problem, it also, here's another example of it. It also gets me really concerned about the straightness of the pin itself. And this granite block, this is what this is really good for, is I could take and actually see, this needs to be really clean, can't have anything on it here, so I'm going to see if that's bent, or I'm going to see if it's wobbling. A more accurate way to do that is with what we call a set of V-blocks. And what we could do is support it out on its edges like this and rotate it around. You'll actually see it wobble. And if you want to get even more accurate yet, then we get into using, now this isn't a metal granite plate, so I have to be careful here. If you can look right here, with this metal base here, I just don't know if these are precisely set up and down. This is for doing Harley-Davidson crankshafts, the tool that we have, but this has a metal base that's really nice. So I'm just going to be really careful. If this was metal, these are pretty cool. You lock that on, this becomes a magnet, and it's real nice and stable here. But what I'm going to do is just get this set up here, show you what this looks like. Should get this one down for a second. If I bang this tool around, am I going to hurt the tool?
Yes.
Yeah, I absolutely am. So I'm going to take this. Why am I trying to go really far out on the pin?
So you get more of a better test, because if you were supporting it here and you had a bend out here, then you wouldn't actually find the bend.
Right, I could, if I did it, really close like this, am I really doing much? I mean, I could still rotate it, but nothing like, isn't this how it's actually in the transmission in the engine?
Yeah.
We support it on its end. And so here, I'll just rotate this around, and I'm going to look and see if I get a wobble out of my gauge. I got to make sure that this is preloaded enough. I'm going to go ahead and slide this out of the way. Do you see how I have a lot of preload on there?
Yeah.
Yeah, you don't want to knock it over. This is not ideal. You guys can do the same setup over here, but I'm just doing this for purposes here, so I go ahead and rotate that around. Another thing that we could do, just slide this guy out of the way, is we talked about this earlier. This is a good way to test your shaft, okay? And then if this had a gear on it and you just wanted to, maybe you didn't want to disassemble the whole shaft, you just wanted to see if it was bent before you disassembled it, just use a bigger V-block that has the height so that it has room for the gears. Does that make sense?
Yeah.
Okay, and this is how we do crankshafts. Sometimes what I'll do is I'll take a couple of these and then I'll actually just put 2x4s or something under it, because these are what are stable, and I'll just keep getting it high enough in the air so that the webs of the crankshaft have room to rotate and give me that clearance. We do have a suspension tool to check for bent forks, axles, all kinds of things, and that's over in our suspension area. That works great for crankshafts too. So for right now, I want to make a point here that I could go ahead and check this, and what I would want to do is get on the bearing surface. Okay, so I'm going to go ahead and check Brian's shaft here. That thing straight as an arrow?
Oh, yeah.
Okay. All right, good stuff. Now this obviously doesn't allow us to check in the middle here. If we have a problem, if it's bent so bad in the middle, you're going to see that hump as you rotate it around. On this case, I would always go over here, check both sides of it. Go ahead, Chris, question?
What if you slipped on one of these bushings?
Sure.
Then you could test it in the middle.
Sure, let's do it.
But it might fall into that oil port.
Well, but we know it's there, right? So watch this. We're just going to go up to it. here, and then I could just, you know, lift over it here, you know. I mean, you're gonna get an idea. If that thing's bent, it's really, really obvious. I wish I had something here that was bent. Here's a good example, actually, of a way we could probably falsify it. Why don't you guys go ahead and take that back? Do you see how there's some silicone or something, there's some crap on this shaft?
Yeah.
First, we'll just try it and we'll see if it's bent. It doesn't appear to be, but if I put this on here, that should cause me to have some deflection. See that?
Yeah, wow.
So there's a good example of, because what you can even watch. Okay, watch what happens to the gauge when I do that. So as soon as that debris gets on there, that'd be the same thing as a bend. It's going to alter that shaft on there. We take this and go to the middle here. I'm curious what it'll do too. Yeah. Well, did you guys notice that when it was straight straight as an arrow, and with any kind of little bend, we get deflection. I want to talk about, make sure that we're also thinking about that we're going to measure this pin. The other thing I want you guys to notice about your tool here, I think you guys are well informed of this, is how you have a thin part and then a part where it's thicker. So you got this thin part. When you can measure something, try to grab on to where it's thicker. Why is that?
Real estate.
You're getting a little more real estate. The only thing is, if there was a big burr or something on here, your thin one might be better so that you could grab just a small portion of it and check it in multiple spots. Make sense? So on your lab sheet, you're going to see that I'm asking you to do that. Another thing on your lab sheet that I'm asking you to do is to measure your shift shaft forks, the pin that they ride on. Okay? And you'll also notice I asked you to measure in 3 places. Does anybody know why?
Because it can be different in 3 spots.
Yeah. Another thing that I always like to do with these is take a set of forks like this and slide them back and forth, okay?
It's bent, it won't move.
Yeah, if they're bent, it won't move, or it's gonna be hard to move. It's gonna hit a point and it's gonna bind. Does that make sense? Do you guys see where a granite block is such a great tool for inspection? Just look at it, I got this nice surface here that the edge of the fork is sliding across. I'm not scratching anything or hurting anything. So that's another way to check the pin. But the point is, we're gonna look at Brian's good and used one here. I'm gonna take and set these off for a second here. Do you notice how there's wear marks in there? There's rings from where it rode?
Yeah.
These, when you're shifting around this, guys, there's no doubt about it that everything binds. Everything kind of moves around. So if you have a lot of hard shifting in an area, if I have a bad shift fork, I always check the pin and I always check the drumming. Everything that's attached to that directly with that fork with the damage is going to be heavily inspected. Can you kind of see where he's got a couple of witness marks here? I'm not worried about it. It's not like I could feel with my fingernail, or it's not like it's real excessive. I mean, if I could feel that with my fingernail, I would be worried about it. Make sense? So that's how you're going to check that out. All right, guys, another procedure that we're going to use out of the service manual is to check the shift fork side clearance. That's where it's installed on the gear, and then you're going to take feeler gauges and keep putting them in here until you find the thickest one, and then match it up to the service manual and see if you're in spec or not.
Do you always check on the end of the shift fork, or do you check?
You check all over.
Okay.
Yeah, if you had a bent fork, that would be a possibility of a problem as well. Okay. So, yep, great question there. And just a light drag, you know, not something where you're trying to force it in there. You'll see you have a range for the specification in your service manual. On your guys' lab sheet, you're simply going to you're going to measure it, you're going to check the spec in the manual, and you're going to circle good or bad. Make sense? All right, we are going to move to shift drums.
Wow, thank you.
This one's out of a Buell. High performance, aluminum. Would not last very long. Aluminum shift drums are just purely for lightweight and high performance. This guy here is obviously something that I've scored somehow over time here, and I haven't inspected this one yet, so I'm excited to do so now. I'm going to look for any items of wear, any problems. The first thing I want to point out, so that you guys get an idea of where my eyes are going to go, why don't we just start at the end here, and we're going to look at our star. do you guys remember this is where the detent goes, or they call it, some manuals call it the cam stopper, and it basically has a spring that holds it into position.
Yep.
What was the half moon that I called? Neutral, and every one of these is a gear, right?
Right.
Okay, so I'm going to look at this. I'm going to look for any divots or scoring or galling or whatnot. It's looking pretty good to me. Chance's question was this a 5-speed? Even on a 6-speed, they just won't use the last one if they don't have the gear set in there. Make sense? Okay. Well, let's go back to this here, and what I want you guys to see is when you shift this transmission, it goes along this channel, and once it hits this, that's what moves the gears back and forth in and out of engagement. Does that make sense?
Yeah.
Okay, so that pin, we said if we had damage, we're going to be really focused where it rides. You only got 3 shift forks and 3 channels, so you're going to match up the one with the damage and have a lot of focus on that. Let's just take a look here, and let me show you. This is the good thing to know about all shift drums. This Honda, Suzuki, Harley, doesn't matter. Where all of the wear happens, guys, is right here at the transition. Okay, this is where the wear happens. So, oh, there it is. I see a spot. Do you see here at this transition where that aluminum's kind of gouged in there a little bit?
Yeah.
Okay, that little bit of damage right there junked this $100 and some part. That guy right there. Without this being blown up like that, you guys bet that's hard to see?
Yeah.
So how do you think I determine these over the years as a technician? Or how do I do this at home?
Magnifying glass.
A magnifying glass. The trick that I do nowadays, guys, I've really gotten the habit of this, is use your iPhone or use your phones and take a picture of it and then blow it up. So if you don't have a magnifying glass, we've got the technology, most all of us, in our cell phone now to take a photo of something and then blow it up and get that attention to detail. Okay. Next thing I want to do is let's switch to a traditional metric. This is a Yamaha one. Oh, there it is. So you guys can see that with this blown up, it's extremely obvious. Now, I want you to build a relationship here to transmissions. Are you guys realizing that this is a very small movement to make a part become failed? We're not talking about half a thousandth of an inch or excuse me, a half an inch or something else. I mean, we're talking thousandths of an inch that this isn't able to do its job or to move back and forth, and the parts are junk. So just focusing on that one area of the shift drum. Here's another bit of the star pattern here. You're starting to see that. In your lab sheet, there's a part where I ask you to check the bearing. And I also ask you, of the entire transmission, what is the most overlooked bearing inside a power sports transmission?
That there.
This one right here. You know why? They take it out, it's out of sight, out of mind, and then they don't mess with it anymore. So this one's often overlooked. This bearing does not get any RPM. All it ever gets is this. Make sense? Yeah. So that's an important thing to think about too. We called this the cam stop or the star on these shift drums. And do you see where these pins are?
Yeah.
On your lab sheet, there's a place where I tell you to check the paw pins, and that's where the part of the transmission comes around. And when you shift, you know how you go back and forth and it grabs this and either rotates it one way and pushes it the other, or pulls it back and forth? There's a part in there on your lab sheet where I say grab your shift paw, the hook if you will, and inspect it. If you have wear on this pin, do you have wear on the paw?
Yep.
So every part of this transmission, would you agree, has a mating part?
Yeah.
So you got to really build that relationship. Step 1 to step 2 to step 3. And you know, if the only place I have wear on this shift drum is over here, then you're not going to see wear on the pins on these two. Do you still have to inspect them?
Yeah.
Every single little piece of this. And guys, this is a really good introduction to what damaged parts look like. Let's look through your lab sheet here and see if there's anything more that might be deceptive here. The shift fork shaft pin, that's these guys. Should probably give Brian his back. Measure multiple spot. Oh, here's an example. And I ask you what secures this into the engine case. Some type of bearing retainer or a bolt or a cover. Here's an assembled Ninja motor with the shift drum still in place. I'm gonna go ahead and just take the shift shaft out completely. Here's those paws that grab onto these pins. This one just doesn't have a cover on it like the shift drum that I just had. So when we rotate this back and forth, it grabs the shift drum. Here's the detent that you guys have seen quite a bit. What do you check on this? Do you remember from your two-stroke?
That it snaps back.
The spring, you want to check that there's free play in that there's not a missing shim that's causing this to lock up. And then this rivet. The rivet is a part that you need to check. On high performance ones, what are these made of?
Aluminum probably?
No. This will always be a steel part.
Oh.
No, instead of a rivet, it has something else.
Oh, bearing.
A bearing, good job. Okay, so is there a chance this shaft could be bent?
Yeah.
From accidents. Remember where the shift lever hits the ground and then bends this up? So check this out. I could take this and try and see if I have any damage there. I don't need a lot of specialty tools. That's a nice, quick, and easy way to check that out real quick. The other thing that we're going to inspect in here is, do you see this plate right here?
Yeah.
Look at, guys, that's what's holding the shift shaft pins in that the forks ride on. Let's flip this over. Do you see those shafts now?
Yeah.
So I'm going to ask you, on your motor, what holds this in place? It might simply be that they just put a bolt over the end of it, but the one thing I noticed about shift shafts is they're always floating. They're not like locked in there, something isn't bolted against it. It has a little bit of float to it. You can see the channels that this is riding in here. So on your particular motor, look for some type of fastener that's going to cover up the holes. That means you put the pin in, and on this one here, do you see where Kawasaki has it where they actually insert this bearing retainer into a slot on the pins to hold that place? Yours just simply, like I said, might cover it up. Okay? All right, another area that is overlooked, and I fixed one transmission in the last few years that was completely disassembled and didn't need to be, and that is this shift. This is the shift locator pin, if you will, or the neutral pin. It does not mean neutral as in a gear position. What it means is neutral as in it's not upshifting or it's not downshifting. When I hit the shift lever with my foot on the other side, you see where the spring goes away from the pin? What do you know that spring is doing to that pin? It's stressing it. It's putting possibly a little divot in it. People don't look at the spring and then the pin itself often enough. Go ahead and look at this one and look at the damage. Can you see it in there?
What will that cause? What kind of problem?
It'll cause an overshift or it'll cause an over upshift or an over downshift, because now the pin allows it to travel further. And when you try to overshift, what's that do to two sets of gears?
Locks.
It tries to bind them. Okay, so you guys see the divots on there?
Yeah.
How easy is that to overlook? I want you guys to get this in your head now. This is a wonderful opportunity.
Look at this side.
Oh
yeah.
And that can be replaced from the outside.
Oh, absolutely. You don't have to split the cases. This is the last transmission that I fixed. It was with a student. It was on a Polaris ATV. It had been to 2 shops. It had been to our school, disassembled twice, and finally he said, there's nobody could fix this. It can't be fixed. I split the cases with him. We took it all the way back apart, put it back together, test rode it. It was still trying to bind 2 sets of gears together. I was thinking, what could possibly cause that? And I'm like, have you checked everything? So we decided to take it apart one more time. Upon disassembly, I was really focused on the shift shaft, and I noticed it had a little bend in it, which definitely is not good. And I had the spring actually had a big dig mark in it. And once I looked at the spring, then I went to this and went, no way. What a classic mistake. I mean, myself included, guys. I let him take that whole transmission back apart without checking the outside parts first. But two repair shops, and then at the school there must have been 12 sets of eyes looking at that transmission, and it did not even need the motor pulled and was 100% fixable from the outside. So, pretty cool story. I guarantee he hasn't forgot that. How about your big straight blade screwdriver? I'll just go ahead and operate the detent. So, I'm making sure that this moves free. You see that? We've talked about that in our two-stroke stuff. So I'm not wedging, or I'm wedging lightly, but I'm not trying to cause a bunch of distress in there. If that didn't have the right setup, the right bolt or washer under there, when you tighten that bolt down, what happens to the cam stopper? It locks it in place, so you guys are going to look for that. What secures the shift shaft pin? We just discussed that. That was that bearing retainer. Inspect the shift drum. What are you looking for in the channels?
Gouges.
Divots, gouges, folded metal. Shift drum bearing, good or bad. The shift drum stopper, detent arm, and spring. That's what I just did with the screwdriver. Inspect the pins on the star. What are you looking for?
Gouging, scarring.
Shiny spots, wear, divots. Inspect the shift shaft. That was this guy. Inspect the shift shaft return spring. Let's make sure we're noticing which one. You got to read the whole question, because your service manual is probably not going to call it the same exact part, okay? This is the shift shaft, so when I say the shift shaft return spring, think about what's attached to this, okay? Kawasaki uses these spring-loaded little ones here, okay? That has to work and function, obviously, but when I talk about the return spring, what is this returning, by the way? So on the motorcycle, what's it returning back to a neutral position?
Your shifter.
Your shift lever. Okay? If this spring is ever broke, if you ever have a customer that comes in and his shift lever is just dangling down, or it stays here, but it's just floppy going up, what's broke?
Spring.
That spring. X-ray vision, right?
Yeah.